and welcome to our panel discussion, Earth to Energy, Reimagining the Future of Energy Resilience. I'm Melissa Floyd, Vice President of Corporate Communications and Marketing for Strite Energy, and I will be your moderator today. We are going to be examining the U.S. and how it is keeping up with this skyrocketing demand for energy. And we're also going to talk about the future of the battery supply chain here in the U.S. so that we can ensure energy security and resilience. And then following that, we'll do a lightning round where we'll give each of the panelists the opportunity to share their key takeaways with the audience. So without further delay, I'll get into our introductions. Scott is our Vice President of our Essential Power Division for Strite Energy. And Scott champions clean, renewable energy opportunities for Strite Energy and actively works with utilities and original equipment manufacturers to deploy sustainable, long-duration energy storage projects in the United States. Scott is also the chairman of the Flow Battery Industry Group, which was formed by Battery Council International to bring together flow battery manufacturers and suppliers to develop approaches to address key common issues facing the industry. Thank you for being here, Scott. Next, we have Dr. Vic Singh. Vic is Senior Vice President of Technology at Dragonfly Energy, where he oversees the development of next-generation lithium-ion batteries and manufacturing processes, as well as optimizing solid-state battery chemistries and for deep cycle applications. With his expertise in chemical engineering and material science, he has built an advanced team of research and development specialists that are scientists and engineers across various disciplines at Dragonfly, which is headquartered in Reno, Nevada. And finally, we have Dr. Eric Sporky. Eric is Senior Analytics Advisor for Energy Storage at the U.S. Department of Energy, Office of Electricity. And Eric has a passion for energy-related research and has advocated a wide range of battery systems and other energy storage technologies, particularly for grid-scale and long-duration energy storage applications. He was previously the energy storage materials lead in Sandia National Laboratory's Grid Energy Storage Program, and he recently served on the DOE's Energy Grand Storage Challenge National Laboratory Coordination Team. Eric seeks opportunities to connect technical innovation with market needs and priorities toward reliable, sustainable, domestic grid-scale energy storage deployment. So let's jump in to the Q&A portion of our agenda here. And being at CES, this is a place where companies from all over the world are bringing their latest innovations. But one thing they have in common is they all need power to function. Electrification has undoubtedly driven our dependence on batteries, and in particular, lithium-ion batteries. And we all know that China is the global lithium battery production leader with a projected 70% of total capacity by 2030. And even though the US lithium battery production is scaling up 10 times, it'll still just be 10% of total global capacity. So my first question is for you, Vic. What does the U.S. battery supply chain look like right now for lithium batteries? And how should it be improved to eliminate dependence on countries of concern?
Awesome. Well, thank you for having me. And, I think the supply chain in the U.S. has changed dramatically in the last 5 years with the Inflation Reduction Act and the bipartisan infrastructure law. You saw a lot of impetus, whether it was private industry, government, to onshore manufacturing technologies associated with clean energy. So, back 5 years ago, Tesla was essentially the only one operating a gigafactory in the US. There weren't really any plans for additional battery manufacturing facilities in the lithium space. Now we're planning to extract lithium from the ground. Tesla has expanded, and we have companies like Dragonfly that have popped up as well and started producing battery packs in the US. So it's changed quite a bit in the last 5 years. I think we've made a lot of progress, but it's still quite disconnected. We're in the process of starting to pull lithium out of the ground, but turning that into materials that can actually go into batteries isn't quite as developed here in the US quite yet. So there's the gaps in the value chain. I think where you typically see those are the highly commoditized, low margin unit operations that are difficult to take out of Asia and bring here, but it's definitely changed quite a bit, a lot of improvement, and still quite a way to go.
Yes, thank you for that. And I'll direct this next question to Eric. From the DOE's perspective, what aspect does diversity of battery technology play in the domestic supply chain?
So remember that the Department of Energy doesn't make, and well, that's not entirely true. They don't make any batteries, let's say that. Not batteries that any of us would have access to. And they've actually funded over the last couple of decades more than 30 different types of energy storage technologies, which includes an awful lot of different types of batteries. So some lithium-based systems, zinc-based systems, sodium, all kinds of different things have been priorities over the year. And I think it's really important to recognize that the DOE is not in the business of picking a winner. In fact, a big part of what I'm focusing on is to try to understand how we can let the market sort of recognize and understand here's where the specific unique needs are, and understanding that there is not a single silver bullet, or lithium bullet perhaps, if we want to talk about elements here, but it's about recognizing there's going to be a diversity of use cases, a diversity of technological needs, and every one of these batteries that gets put together, I like to think of coming from an R&D background, these are unique chemical reactors. They're all different. And so when you think about these types of chemical reactors, they're going to have different properties. So the DOE wants to prioritize creating the portfolio of diverse technologies that are going to be needed for the diverse applications and use cases that we're anticipating that the grid is going to need this year, next year, in 5 years, in 50 years. It's looking at that bigger picture of the diversity of use cases and the accompanying diversity of performance that you're going to need to pull out of that.
Yeah, absolutely. And as Vic said, really getting our domestic capabilities to produce these energy storage technologies is really important. What are some things other battery technologies can learn from the lead battery industry in terms of sustainability and a circular economy approach to energy storage production and recyclability?
Sure. Maybe first I'll just explain this relationship. In a way, like the lead battery industry, they have a strong recyclability capability, and there's this relationship between renewable and recyclable, right? So in a way, recyclable is renewable. If the raw material you draw out of the ground has an energy content, and after you get enough of that energy content in a working space domestically in North America, say, you can just continue to reuse that over and over again. And so in that sense, recyclable is renewable. And so, like in the lead battery industry, we recycle like 98% of our total content. So no new or very small amount of new mineral is extracted on a regular basis to support our manufacturing needs today. So I think an emphasis and a priority around being recyclable is incredibly important.
I think we see that there are a lot of strides that we're making from a public and private perspective to get there for other battery chemistries. Definitely can serve as the model. Yeah. So Eric, this question is for you. What input is the DOE looking for from industry as you work to foster the evolving energy ecosystem?
So I'm, it's sort of funny, as I have transitioned to this new role at the Department of Energy, I've recognized there's this myth that somehow the people at the DOE know everything. That we have the answers and we're just waiting to dole it out to those of you who are waiting to hear our grand wisdom. And the truth is that we are looking to hear from all of you, from the experts, from the people whose livings, whose businesses, whose income all depend on this and the future of this industry. Where are the bottlenecks? Where are the challenges? What needs to actually happen from your perspective? Because we can envision, we can make a flow chart and we can say, okay, we need these steps to put this into place. But it's harder sometimes for us to recognize, is there a policy that's in place that's impeding something? Or is there an opportunity where you could make a suggestion to say, hey, if this was a little bit different? So when we have opportunities, we put out these requests for information, or we have these solicitations that we put out where the federal government is asking for people beyond the government to tell us what's important to you. Please take time to fill those out, because we look at them, we take those to heart. Just as an example, this last year, there were a series of reports that were produced through an initiative called the Storage Innovations 2030. And we wrote a series, I think it was 10 reports, were generated across lots of different long duration storage technologies. And these reports were generated not from people like me or at the national labs going out and reading the papers and figuring things out. They were based on interviews and listening sessions that the Department of Energy hosted, where people from the national labs actually asked and got input. So these reports are basically combinations. They are summaries of the input that we got from industrial and academic and national lab experts who know about what makes these things work. So these reports came together, and I can tell you that those reports, as they came in, helped generate a picture of here's what needs to happen, for example, to make flow batteries or zinc-based batteries cost effective and how to overcome some of these challenges. And I can tell you right now that some of that information, it's read by the congressional staffers who are putting together the bills. So they look at this and they say, wow, okay, the Department of Energy created this conduit from what the real world said was important through the Department of Energy to Congress, and that can result in real money that flows out as opportunities and what needs to happen to help move forward and address some of the bottlenecks that people bring to bear. So when we say, please tell us what's important and where there's opportunity or where there's bottlenecks, across the spectrum, from supply chain to policy issues to manufacturing challenges to workforce issues, which is something I'm sure we'll touch on here at some point. But all of those things become important. So the Department of Energy and the federal government really are looking for that kind of input.
And so Vic, I would ask conversely, from the industry point of view, what are you looking for in help from the DOE to further the energy storage, R&D and deployment goals that you're working on?
Sure. I mean, I think DOE has always been very good at identifying the lower TRL technologies that are needing investment, are high risk, but in the case of lithium, have the potential for us to leapfrog what is happening in Asia. So this can be new ways of making the batteries, this can be new ways of new materials that go into the batteries that give you more supply chain resilience, or even on the hardware side with the battery packs themselves. So what I've seen from government, the obvious answers are the bipartisan infrastructure law, loan programs office out of DOE, pumping in billions of dollars into the industry to onshore. And that's important because the minute you're done doing these tests at a prototyping and lab scale, you're talking about $100 million, billion-dollar investments. And that's not straightforward, and they've definitely come in and supported that gap. Longer term, as a material scientist and chemical engineer, I never thought I would be thinking about tariffs and Xi Jinping and Taiwan and lithium mines in Africa and cobalt mines and refineries in Indonesia. I never thought I'd be thinking about these things to that level. So I'm not sure I have a great answer as to what specifically I'm asking from the government, but I do think there's some work that could be done, as the government looks at geopolitical initiatives. How can they better understand the tools they have at their disposal domestically already, whether they're Stryten Energies or smaller firms like Dragonfly or the national labs, to pursue those goals in an efficient manner?
So what I hear you saying is we really need to work together to be competitive internationally at a global scale. So Scott, do you have anything to add to that?
Yeah, I wonder sometimes if somehow the communication could get better between DOE and industry, such that we zero in on high priority projects. I think DOE tends to focus on, like Vic said, the low TRL type projects. Industry is, on the other hand, they're competing for dollars, and they tend to sometimes stretch what is TRL ready. And if we could somehow come together in our communication and really identify those technologies that are high TRL, then we can move the dollars to the next stage of development. So we need the dollars to start going into volume and scale and getting the cost out of the process. And I don't know that we move in that direction fast enough sometimes.
Yes, I agree. And I think there's also an opportunity, not just with collaboration with the government and industry, but collaboration within the industry as well. So Vic, what role do you think partnerships play in establishing a competitive domestic battery supply chain and production ecosystem?
I think they're extremely important. I mean, batteries, the cells are commoditized, the raw materials that go in are commoditized, and the energy that's being output by them is largely commoditized now. So to be competitive in that sort of landscape, you need to be at scale and you need to be extremely efficient. And so, you know, in Asia, what we've seen are partnerships, but more importantly, I think what we've seen in Asia is folks tend to vertically integrate. So, you know, a cell manufacturer is making their own cathode active material or their own separator, and they might actually even be making their own battery packs and recycling some of that material as well. That's easier to do over the course of decades as you grow an industry. If you're trying to do it quickly, I think that's where the partnerships can come in. It's not going to be possible for the companies in the US to vertically integrate as quickly and in the same manner as you're seeing overseas, but partnerships can come in and bridge some of those gaps. So when we think about our products being more cost competitive and effective in the marketplace, exposing them to new markets, helping us scale is one piece of that puzzle, and the Stryten partnership we've established is definitely a key to doing that. So I think they're very important, and I think they can help you know, all the players become more competitive long term without necessarily having to use the same playbook they're using overseas.
Do you have any thoughts to add to that, Eric?
Oh, I have thoughts about everything, but I think one of the things that the Department of Energy has recognized recently is that there's two ways to think about how to provide support into the industry. One is sort of finding a single source. So somebody writes a proposal, the federal government reviews that and says, you know, the Eric Sporky Battery Company is going to get $10 million to go develop this program and do this demonstration. The other way to think about it is to say there are certain common challenges that as a number of different companies or a number of different elements of an industry are all trying to rise sort of in parallel, and let's be clear, there's enough work for lots of companies. Competitive as you guys all are, there's room for lots and lots of different companies to have impact here. So where you can find sort of those pre-competitive opportunities, whether it's recognized maybe as a low TRL, low-hanging fruit, those pre-competitive opportunities can help sort of, you know, the rising tide floats all boats, and at the same time as sort of raising everybody up is it allows creation of the ecosystem where there's cooperation and collaboration. So through things like consortia that are studying pre-competitive opportunities, and the DOE just funded three new consortia that were funded just last year, looking at, I believe, flow batteries, zinc batteries, and it might have been lead acid as well. Those three consortia are targeting critical problems that will help everybody move their respective technologies as a community forward, and to sort of create those connected ecosystem and partnerships so that we can become competitive with the vertically integrated, very aggressive entities beyond the United States. In some ways, these non-lithium technologies, we have a special opportunity in the United States right now because, although lead acid's been around for a century and a half, some of these other ones are still just finally starting to break out of the eggshell here. And so we have a real opportunity to get in and to make impact and create these more cohesive, cooperative, collaborative enterprises that allow for greater, broader success that'll be, I think, more competitive in the long run.
Absolutely. Scott, you have any thoughts to add onto that?
Yeah, same comments. I think to the biggest point, there's so much work to do. We've all just got to be working efficiently together. Yep.
Yeah. So Eric, kind of shifting gears a little bit, but what are your thoughts on industry's role in creating a repeatable model of innovation for stationary storage? And how important is that to achieving international competitiveness?
So a repeatable model, I guess I get to interpret what that means, huh? So I think stationary storage it's got some examples to follow, right? So the things that exist that we're trying to build today in terms of stationary storage, right now we're in the process of trying to leverage what we learned from vehicle technologies, which built off of portable electronics. So each of these times that lithium ion has really gotten this big step up, it's gotten a step up because there was a sort of a formative technology space that allowed that to move forward. There's an opportunity to continue to do that for stationary storage, where we can again sort of take what we're learning from the vehicles, for example, and the infrastructure and the manufacturing capability. But there's another opportunity to sort of say, how else could we think about bringing in other technologies. So if we recognize that lithium ion is an amazing technology, if you look around this room, this giant room, the number of things people are doing with lithium ion batteries, including this thing behind me, it just blows my mind. It is truly baffling and amazing. There are other places where you don't need that battery. You could do better with something else that's a better fit for what's going on there. So but those other technologies don't have the same benefit of they're not putting them into cars. They're not putting flow batteries into cars. At least I haven't seen that yet. So it's possible. I'm not saying it couldn't happen, but they used to make sodium sulfur in cars too. But there's different ways to think about how are you going to leverage that. So there's a little bit of a disadvantage in terms of what we want to try to build forward as far as what can we leverage as opportunity space. And there's sort of 2 points that I want to emphasize there, is that everything else that we consider to be commonplace today was once first of a kind and innovative and transformative. When we went from burning wood in the stove to burning oil in the stove to burning natural gas in the stove, all of these things have transitioned over the time, and at each time there was resistance to that and it moved forward. So those are examples of where there's been large-scale transformation over time that didn't require, well, I was using my wood for something else anyway, so I could put it in the stove, and then I was using oil anyway. It just took commitment to sort of move those things together. The other way to think about that, though, is that you can also identify smaller niche applications. Okay, so maybe a particular technology gets purchased not because it's targeting all of stationary storage all at once. Maybe it goes after a particular application of stationary storage and it builds a little bit there, gets a toehold, and can move forward with a little bit of help from Uncle Sam, and starts to all of a sudden make bridges into real opportunity, real manufacturing at scale, as the following very important thing has to happen. To get any of these technologies to be adopted at scale with any durability and sustainability requires the convergence of technology maturity, which means it has to work and be safe and be reliable. You have to have social acceptance, which means we all together have to decide this is something we want, and it has to have basically policy and legal support for what's going on. So as those things come to bear, as those things converge, you have an extremely powerful momentum, really, that will allow this stuff to carry itself forward as far as its market readiness. And I guess I would sort of type markets in with that policy side of things, because you got to be able to make money off of it.
So Scott, what are your thoughts on how achievable is this from the battery energy storage system side, stationary storage system in the near future?
It's very achievable. I mean, look, a free market economy is excellent at innovation. It drives free thinking and a lot of creativity. I mean, tons of examples. Go back to the early 1900s, AT&T, Bell Laboratories built a big innovation system, right? Zoom forward in time to Google, right in front of the .com, right, world. Again, Google Labs, big innovation system that we produced as an American economy. And so we're good at this. We know we can do it. I think if you look at those examples, the key is this, is they have to be economically driven, right? They can't all be, we like the support and subsidies that come out of DOE. It kind of jumpstarts us on occasion when we need that jumpstart, but they can't be all dependent on those subsidies. So we've got to be economically driven. There's a clear need, the telephone, there was a clear need, and there was dollars behind it to make it happen. And same way with, the .com world. So again, with batteries, we need to have that clear need and economic driving the back end.
Absolutely. And Vic, do you have anything to add from your perspective?
From the repeatable model side, I think about it maybe incorrectly, a little differently, but we're very good, I think, whether we're industry or even private or government, at looking at low TRL technology, figuring out how we want to invest in it, and then putting it forward to the markets and saying, someone license this, someone scale it, this sort of stuff. With the DOE MESC office and the LPO office diving into the battery supply chain now, what they started to do is go a step further and say, we're actually going to come in where typically it's private capital or public markets and help fund the factories. And so the industry, this new technology has come into the US, a lot of money is being poured into it. I think one thing that's missing from a repeatable model for success is the diligence methods being used to look at these investments. I mean, we've had billions and billions of dollars, whether they're investor capital or government money, funneled into low TRL technology, high TRL technology. We have factories being constructed all around the country. We've done this before with the Obama administration. What is a repeatable method to due diligence on these technologies and these companies? And how can you factor in the risk associated not only with the technology or the capital, but also the geopolitics and the tariffs and some of these other components to pick winners? And I think that's something that's missing and needs to be further developed over the next few years.
Well, we all know the path to energy resilience really depends on a strong domestic supply chain, from critical minerals to manufacturing capacity. And I'd like to ask each of the panelists this question. From your perspective, if we could change one thing today about our domestic battery supply chain to be competitive internationally, what would that be? And we'll start with you, Eric.
I think one of the things that I would really love for the country to start to recognize, and there are data today that show this is happening, is that the product of energy storage, and I'm very heavily focused on stationary storage, but the supplies for any of the storage manufacturing, this is an industry that's building. So I would love to see this recognition that developing this manufacturing capability is getting in on the ground floor of something which is going to be around for a long time. And that the benefits of investing in this as a country are much greater than just the benefits of, the 82% of deployed stationary storage that's in California, Texas, and Arizona. Building batteries in the United States doesn't just benefit those 3 states. Even if you never deploy a battery in Mississippi, which doesn't have a lot of batteries, there still can be manufacturing there that benefits this. So the industry as a whole is something that can come on together. There are something like 23 factories that are being built right now that account for up to 23,000 jobs, American jobs, building this stuff. That's a big improvement, that's a big investment, and I would expect it to grow. So I would love to see sort of this recognition that you can get in on the ground floor of building this, and it's creating an opportunity to contribute to a global emerging economy. It's not just where there's local apparent benefit today as to who's installing batteries in what part of the country or for which applications.
Wonderful. And Vic, what would you add to that, to answer that question?
I think I might have answered this one first with my previous answer, because I think the diligence is one thing that's missing. Something that Dragonfly thinks a lot about is we've signed a supply agreement with Ioneer, a mine that's starting up in southern Nevada, quite close to Las Vegas actually. And they have a plan to pull lithium out of the ground in Nevada and it come out technical grade carbonate. But turning technical grade carbonate into battery grade carbonate, and then turning that battery grade carbonate into cathode active materials like LFP or NCA or anything else that goes into the batteries themselves is not as well developed here. So I think looking at the entire value chain, identifying where we're still missing some unit operations, and lastly, what role do our partners play in Western Europe and in Asia? Because it's going to be a transition trying to onshore a lot of this and establish supply chain resilience, and a big portion of that is going to be our partners in Japan, Korea, Western Europe, and these sorts of places.
And Scott, do you have anything to add of, what is one thing you would change to help us be more competitive globally?
Sure, and Vic, thanks for kind of segueing us into this kind of idea of mineral extraction. Where do we go with that? If I had to pick, I think Western Hemisphere mineral extraction is going to be incredibly important. Policy, regulation, alterations such that we can motivate the industry to start bringing mineral extraction to our part of the world. I think it's going to be incredibly important. If I just stick to the theme of recycling just for a second, if we pick technologies that are recyclable, there's a couple of ways to be to bring it onshore, if you will, mineral extraction. You can set up plants that are environmentally friendly, and once if you take the idea of renewable into this practice and recyclability, once you get enough core product into the country, then you're reusing it again over and over again. So there's ways to do it environmentally friendly. We just need availability to the raw materials.
I think that the word I might add as sort of a complement to that is just this concept of long-term sustainability.
Yes.
So that we don't want to have to be consuming things, we want to use things, and there's a difference. So as we use it, you can keep reusing it with very limited. So carbon is very hard to reuse. Once we're done with it, it tends to float away. But other things like the minerals, those with all the clever people who are working on different ways to reuse that stuff, if we can figure out how to make it affordable, I think that this concept of a long-term sustainability approach, I think is going to be really valuable.
Yes, having that sustainable circular economy for all battery technologies is critically important. Let's talk a little bit about the growing demand for energy in the United States. I mean, there's predictions that say that it's going to increase by 27% by 2050, and it's anyone's guess really how much it'll increase, but we know it's going to be more than zero. So Eric, how can the U.S. energy industry keep up with this demand? And what technologies do you see as the most promising to provide grid resilience?
So I'm not going to pick a winner. I think one of the important things to recognize is that what we're doing right now in the country, what the grid is going through, hasn't happened since I think the 1950s. This level of growth and expansion is finally, after all these years, every year they predict, yes, we're going to use more and more, and what happens is we get really good at doing things more efficiently. And so the net benefit is that the grid it has managed to sort of cobble itself together and stay more or less what it is for a very long time. We're finally at a truly exciting time. So those of you who are in this industry, congratulations, because you are pioneers in one of the most exciting times of your whole life. For sure, unprecedented. To try to stay competitive in that, to try to keep up with that, is not going to be any single technology. It's not going to be any single solution. So it's going to require a combination of better transmission, whether that's reconductoring or whether it's more expanded line. It's going, in my opinion, and I'm certainly biased here, I think storage is going to play a huge role in this, not just because of the things that we hear about. It allows you to transfer time, and you can time shift your energy, and you can bring on different energy sources. But what energy storage does at the end of the day is this is your Swiss Army knife. This is your tool that allows you to do so many different things. You can change the time, you can change the nature of the energy. I don't care where the energy comes from, the ability to shift it is really important. If you think about pump storage hydro was originally put in these great big dams that we hear about, like Raccoon Mountain. Those were put in to support not wind and solar, nuclear, which doesn't turn off really, right? So the point is no matter what your energy source is you can use energy storage as a way to make all of these different sources of energy and all of the advancing demand, which is really, we don't know what's going to happen. So when you have uncertainty, I don't know about you, but if I'm going into something uncertainty, I take whatever my best, most versatile tools are going to be into that situation. And to me, what storage gives you is the opportunity to best take advantage of, to be most agile and most adaptable to what's coming. So we want to use energy storage together with things like expanded generation, lots of diverse generation. We want to use it with expanded transmission. We want to use it with better cyber. We want to use it with better controls and programming. All of these things that are part of the evolving modern grid, and we want to be able to couple those with this Swiss Army tool in energy storage that allows us to be so agile and adaptable as we enter something where we just don't know how big the challenge is going to be. All we do know is that this is a period which probably, I'm looking around the room, I don't think there's anybody here that's old enough to have seen the last time this happened, but it's been a long time. So
just building on that, Scott, what are your thoughts about the role long duration energy storage will play in keeping up with the energy demand, and give us some examples of promising technologies that you think are close to commercialization?
Well, if I could just unapologetically pick a winner, vanadium flow batteries I think is going to be super important because they're part of the LDES movement that we're in, right? So long duration energy storage is incredibly important. Basically, the lithium world, I consider it not an LDES solution. It is not long duration. You basically, if you want more duration, you just buy more of it, right? It's basically a 1 or 2 hour solution. and you buy more of it. And then the shame in the whole thing is that it's super high power density and it's super valuable for mobile applications. And we should be using it for that, not for long duration and stationary applications. And so I think in general, we got to get long durations. One of the reasons I highlight vanadium is you decouple power and energy. And it's a much more favorable technology for growing high amounts of energy and long duration for utility companies where you need it the most.
Well, Vic, do you see a role for lithium, particularly to augment some of the other long duration energy storage technologies that are truly 4-8 hours in duration?
I mean, I do. I think you're going to need these sorts of battery technologies to modulate the power output of whatever you're going to put into these installations. But from Dragonfly Energy's point of view, we're really focused on behind the meter at the very end of delivery of these of electricity. And so there, I think there is quite a bit of opportunity still for lithium. If you want distributed storage, if you want to potentially enable a smart grid that's more distributed and has those nodes out there, that might be a little bit harder to do with flow batteries. There you might want to see some smaller installations that are lithium focused. So I do think there's going to be a mix of technologies. I think lithium is going to be around for a while. And just in our industry, we were first movers in RV, recreational vehicles, convincing these customers to pull out their lead acid batteries and put lithium ion batteries in. And these folks are staying out there longer. They're able to go to more sites. They don't have to hook up to shore power as often. We've got ways for them to charge the batteries while they're driving. So we've actually seen that flexibility afforded to customers that you're talking about in the future, with large storage installations. We've actually seen that play out with our customers behind the meter over the last 10 years at Dragonfly by just going in and providing lithium solutions to RV and other niche off-grid markets.
I think that there's a really important, you talked about sort of the repeatable model business concept. This is an example of where, as we start to see success in these specialized cases or slightly smaller cases, the behind the meter applications where there's success, those concepts can be translated to other applications. So learning more about, hey, here's an example of where something really provided maybe even an unexpected benefit to this particular system, the more that the community at large learns about what's going on there, the more all these creative minds that are running around here today can start to piece together and say, yeah, that's great. Now imagine if I could do it instead of for a 2-hour system. What if I had a 12-hour system or a 24-hour system? Or I had a really big system even for just 15 minutes. Whatever it is, you start to think about different ways that you can plug into that. And so success, I believe, is going to breed more success. And whether that's flow batteries, lithium-ion batteries, or even non-batteries. So let's be clear that there is more than just battery storage in the world, and I think that there's opportunity for some of those things to play a role too.
Well, we're a little bit over time, but we have just one last question to ask, and that's really for you all to summarize the key takeaways you would like for the audience to have after hearing what we've discussed here about energy resilience and bolstering our domestic battery supply chain. What would be the key takeaways you would like the audience to have? So I'll start with you, Vic.
I think whether you're in government, industry, or in the investment sector, really sitting down now that we've pumped a lot of money into this industry and we're poising ourselves to either have wasted it or be competitive in 5 years. I think now we really should sit down, all three arms, and try and figure out what are the methods that define how we pick the winners and make targeted investments to make sure we are competitive long term. And I think it gets back to my diligence comment. I think, with new technologies and them entering the marketplace so quickly and having a lot of noise and early on having interest rates really low, it's easy to just take a shotgun approach. And that works at the beginning, but now that we're talking about trying to compete with China for the next 2-3 decades in these markets, we need to start being really targeted and efficient with those investments. And how we do that, I think, is something I hope everybody's thinking about now that we've gotten through this kind of shock to the system, if you will.
Scott, what are your key takeaways for the audience?
Sure. So I've talked about a couple of those. I've talked about mineral extraction. We've got to get the cost down. We've got to be scalable. But let me talk about the one that I think, a third one that I think about a bit is distributed energy resources. I think we've got to find a way to get distributed energy resources into the marketplace as an economic player. In today's world, it's frictional. So, for instance, if I'm a homeowner and I have solar on my house, the utility doesn't want to buy it back from me necessarily, right? They don't want to compete with me as a producer. And there's friction there, and if we can find a way to eliminate that friction, we can get a lot more players in the market helping us innovate along the way.
And Eric, I will give you the last word.
Okay, so I guess what I want to sort of emphasize is that certainly in the Office of Electricity, the goal of what we're trying to achieve is for there to be secure, resilient, reliable, and affordable electricity delivered to every American. That is a principal tenet that motivates what we're doing. And it's not about one particular agenda or another. It's about basically making sure that those priorities are met. Delivering electricity, that's the goal. What really excites me, and I love seeing people who are coming and engaging and thinking about these things, is just how many people are on board with finding solutions and finding opportunities to do that through new technology development, through policy innovation, people who are working in law, people who are working in government, people who are working in supply chains and manufacturing and training. The whole country really has a chance to get behind meeting this goal at an unprecedented time in what this country is going through. So I hope you guys are as energized and excited as I am about the opportunity that's before us, because boy, it's really a tremendous time to be here, and I'm so excited.
Well, I would like to thank each of our panelists for sharing your insights today. I think it's been a really interesting conversation. And I want to thank our audience for sticking with us to the end. And if you have any questions for our panelists after we conclude, please find them. They'll be in the booth for the next hour, so you can ask your questions directly to them. And just a quick reminder that we do have another panel discussion tomorrow at 11 a.m. It's Scaling Energy, Myths, Microgrids, and the Race to Resilience. So I'd like to invite everyone to return for the next panel discussion tomorrow at 11 a.m. And we also have multiple tours scheduled of Reluctance behind us, which is our mobile microgrid example. So please, stop by the booth and learn more about what we have back here. And again, thank you so much for being here, and enjoy the rest of your day.